And this is going to be a combined lesson with 1.6 and 1.7. So as you can see from the title, 1.6 deals with two-dimensional figures. Again, there's some vocabulary here. Just like in geometry, there's tons and tons of vocabulary. But when you look at a polygon, it's just a closed figure. The vertex is where there's an angle. It's a point. So anytime there's an angle formed, that point where it's formed is the vertex. We kind of looked at that when we looked at angles. There are two types of polygons. There's concave, convex. Okay, concave is exactly like it sounds. It caves in. So if you look down here, you've got a cave in. So this is concave. It caves inward. Convex is anything else. So the rest of these are convex polygons. These are not polygons. They're not completed. It has curves. It's got an extension on it. It's not closed in. Again, has curves here. This is not a polygon because they're connected. Now, if you covered up one of them, so I'm going to do that right here and show you what it would look like if it were a polygon. So if I did something like this right here, now that singularly would be a polygon, but not together. So just a recognition there. So names of polygons. So when you name a polygon, these are the particular names that you want to look at. Starting with three sides, you got to have three sides to make a polygon. So triangle, quad means four, pentagon, hexagon, heptagon. You may also hear septagon, it's the same thing. Octagon, nonagon, decagon, hendagon. It's actually hendecagon. That's hard to say, hendecagon. Dodecagon, and anything over 12 is named by whatever it has. So it would be a 13agon, a 15agon, you see up here. An equilateral polygon is one where all the sides are the same. Equiangular is where all the angles are the same. So if it's regular, is one where it's both. So the dash marks mean the sides are the same. The arcs mean the angles are. So this is 1, 2, 3, 4, 5 sides. So that would be a regular pentagon. Irregular is just a polygon where not all the sides and angles are equal. So some formulas related to two-dimensional figures. Perimeter, area, circumference. So when you look at these formulas, P stands for perimeter, and you get that by adding all the sides. If it's a square, you get this reduced formula because all the sides are the same. If it's a rectangle, you get 2 lengths plus 2 widths, so you get 2L plus 2W. Circles have circumference, and we use the symbol pi. We've seen that on the calculator, and then here are the area formulas. So one of the things you'll learn too in geometry is there's lots and lots of formulas you have to know. So here's some real quick problems dealing with two-dimensional shapes. This first one says name by its sides. So 1, 2, 3, 4, 5. So that's a pentagon. It's concave because it caves in. And it's irregular because concave cannot be regular ever. A regular has to be convex. This one would be 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So that's a nonagon with 9 sides. And everything is marked congruent, angles and sides. So that would be a convex, regular, nonagon. Okay, what's a stop sign? 1, 2, 3, 4, 5, 6, 7, 8. So that's a octagon. This is 1, 2, 3, 4, quadrilateral. 1, 2, 3. Triangle. It's kind of not, because if you count the flat edges, then you got 1, 2, 3, 4, 5, 6, and you would call it a hexagon. So it's really on how you view it. If you're looking at just the triangle inside or all the edges on it. Find perimeter, and you get perimeter at all the sides. So this would be 11 and 11 because this is a square. So it'd be 44 feet. Circumference here would be pi times the diameter. So on your calculator, you do 12.8 times 3.14159, blah, blah, blah on your calculator. Next one, let's take a look at number 9 here. It's a multiple choice. Vanessa is making a banner for the game. She has 20 square feet of fabric. What shape will use most or all of her fabric? So here, since it's square feet, we're dealing with area. So if it's a square here, with a side length of 4, the area would be 16 square feet. So that uses a lot of it. A rectangle with a length of 4 and 3.5. So there it's 4 times 3.5. And if we do that, that's 14. So not as much. A circle with a radius of 2.5. So a circle is pi r squared. So my pen's not writing very well here. Sorry, 2.5 squared. So here, you want to use your calculator. So I've got pi times 2.5 squared. And that comes out to approximately 19.63. So that's pretty good. A triangle with legs of about 5 feet. So with a triangle, it's base times height. So talking about a right triangle, so the height is 5 and the base is 5. So area is 1/2 base times height. If you do that, you get 12.5. So the circle is the best option there. Number 10, this last one. Here you want to find perimeter, but to get perimeter you have to have the length of the sides. So what I would suggest here is draw a picture. So you have a triangle. So I'm just going to draw a triangle. A has coordinates -1, 2. B has coordinates 3, 6. And C has coordinates 3, -2. Now if you want to use graph paper, you can. But then what I have to do is I've got to do the distance formula. So here's some quick review. So distance formula is x1 minus x2 squared minus y1 minus y2 squared, all under the square root. So you got to work that out. Remember, you label like x1, y1, x2, y2, and you'd have to find the distance here to here. Then you'd write that down, and then you do each of the sides here to here. Write that distance down, here to here. Write that distance down, and then add them. We're not going to go through all that. Just wanted to explain to you how to do that problem. So in 1.7, we're looking at three-dimensional shapes, polyhedrons. I'm not going to go through all of these. You need to definitely look this over carefully, be able to identify just some quick points. Bases are not just top and bottom, it's the face on which the solid sits. So the base of a cylinder is a circle because that's how it would have to stand. A cone would also be a circle. So it's the face on which it sits on, and face is another name for the side of the polygon, or sorry, the polyhedron. So here are some particular examples with some different Platonic names. Tetrahedron. So if you look at a tetrahedron here, it's made up by 4 equilateral triangles. Okay, and the reason these are platonic solids is because their faces are all regular polygons. So here a cube is made up by squares. Squares are regular polygons because all the sides and angles are equal. Octahedron made up by 8 equilateral triangles. Dodecahedron, pentagons, and then icosahedron, 20 equilateral triangles. So again, just some different names, things that you'll have to just kind of learn on your state test. They may refer to a tetrahedron, so you need to know what it looks like and how it's made up. So again, some formulas for three-dimensional shapes. I'm not going to go over all these either because you will need to probably just refer to these. But also, Ms. Hall has a good formula sheet that I believe she shared with you that you can refer to help you as well. So some real quick problems here to look at. It says determine whether the solid is a polyhedron. Okay, this is not a polyhedron. Okay, polyhedrons are made up of just faces. Well, because it's a cylinder, it's round on the outside, so it does not have faces. This, on the other hand, is a polyhedron. It has what looks like a rectangular base and then triangles around the side. So if we were to name that one would be named a rectangular pyramid because the base is a rectangle and it's a pyramid because it comes to a point. Find the surface area and volume of each solid to the nearest tenth. Okay, so number 3, I'll expand this a little bit so I can do some work in here. Surface area is really just adding the area of all the faces. So if I do this side right here on the front, that's a square. So it's 3 by 3, so that's 9. Well, that means this side over here is 9. If I do this face right here, that's 4 times 3, which is 12, which means this back side is 12. Then I've got to do the top and the bottom. So if I do the bottom here, that's a rectangle. It's also 4 by 3, which is 12, which means the top is 12. So then all I do is I add all those together. So I have 9 plus 9 plus 12 plus 12 plus 12 plus 12. And if I do all that, that's 24, 48, and 18 would be 66. That'd be 66 centimeters squared. Area is in square units. Excuse me. So what about volume? How do you get volume of this solid? You do length times width times height. So I'm doing length times width times height. So all I'm doing is multiplying all those. So volume would be 3 times 4 times 3, which would be 36, and that would be centimeters cubed when you talk about volume. All right, how about number 4? So when you talk about a sphere, you're not talking about perimeter or anything like that. You are still talking about surface area, but it has a special formula. The surface area, you'll see SA used a lot, it's 4 pi r squared. So we do 4 pi, r is our radius, which is 6 here, 6 squared. So obviously you want to have a calculator handy. So 4 pi, type in 6 squared, and you get approximately 452.39 inches squared. Then volume formula is 4/3 pi r cubed. Okay, so you do 4/3 pi, again 6 cubed. So again, use your calculator. When using your calculator, put the 4/3 in parentheses too. So parentheses 4 divided by 3 pi, in parentheses 4 raised to the third power, and we get approximately 268.08 inches cubed for volume. So some formulas, some things you'll have to figure out as you keep going, but the big thing here, lots and lots of vocabulary for names of shapes that you'll need to learn.